Okay, so I'm going to be discussing now. Elements of Unix shell we haven't had time to talk about, with a particular focus on certain ways of in which abstractions associated with the Unix shell can be used to create composite commands, compound shell commands, where, for example, one program's results are composed with another in a variety of ways, conditional ways, command substitution, as well as the pipes we've already seen. Make some, and in later elements of this lecture recorded separately, I'm going to be talking about shell interpretation, regular expressions, here for 214. Okay, so it bears recollection that if we're in a Unix command environment, an environment such as we operate in under Bash or under C Shell or TCSH, etc. Generally, we have a command which will, when we enter it, it will start up a process, and it takes input. It takes some arguments which specify what sort of variety of its processing it should do, and it outputs often two things here: standard out and standard error. There's also an error status by which it reports back information whether it succeeded or failed. Now, when creating a given command, such this or when formulating a given command, I should say, formulating a given command. So that is where we're sort of defining what we want to do with a command in Unix shell. We can typically abstract away from details of interfacing commands, sort of where we're getting our input, where we're putting our output, and focus on that command. And this abstraction, this capacity to kind of focus on that and hide the details of sort of where the input's coming from or where the output's going from, is facilitated by the use of ASCII text as an exchange mechanism, as often the output from one command and the input to another. Think of doing an ls and then piping it, something we'll be talking about more later, into something like word count or something like sort, etc. So it's very nice that we can kind of create each element of that command, say the sort, and for the moment focus on that, not have to worry about all the details of what particular command line arguments we're going to be using for word count or the exact details of what gave us the textual input we're going to be sorting. So we've already seen that we can use this ability to sort of create these little elements and abstract away from details of surrounding elements. We can use those to create more sophisticated commands by joining up a variety of flows. So we have commands in turn for various components, and we compose them together, say by input from one flowing into another, in various ways. And actually, we've seen one of these ways, pipes, that we'll review very briefly, but there's a variety of others I want to alert you to. So pipelines that we've already talked about allow for composition of commands. So here there's a pair of streams, one for writing and one for reading. Everything written in the output stream is read in the input stream of the other process. So we have one process outputting some stuff, and it becomes the input for another process on the input stream for that other process. And we can connect two commands via pipe if the first command sends output to stood out, and the second command reads input from stood in. And we've seen how they can be specified using this vertical bar in the shell. And I emphasized how the fact that we can use ASCII text helps facilitate this process. There's other environments, such as Windows PowerShell, which allow for using other mechanisms, but ASCII text is very, very handy. Okay, So here, using the diagrammatic representation we had earlier, we had one command associated with one process that's running, another command associated with a different process, and the output from one is fed into the input from another. So, for example, we saw we can do an ls-l, list a variety of extra information about the various files, and we could pipe it into more, so we could see it screenful by screenful. Or we can cat various files that start with marks. We can extract various fields for them, and then we can sort appropriately. Now, one thing I want to emphasize, I had mentioned it in passing, but it bears further notice, is that while it might seem that this sort of use of pipelines, this ability to pass output from one to another, could be simulated by sort of having this first command just output to a file, having the second command read from the file, process that, and so on. While it might seem equivalent, that is, we could replace something like this with a write to a file, a command 2 reads from that file, and then we remove the file. The semantics here are not identical, at least not under Linux or Unix environments. This is actually approximately what happens within Windows, but one of the distinguishing factors of Unix is that these two commands run simultaneously. They run concurrently, that is, in parallel. So command 1 is running command 2, and you'll recall from class my analogy of the bucket brigade. Command 1 is handing off successive payloads to command 2 for processing. So each successive payload, command 1 process, once it's done with it, it passes it to command 2, and command 2 gets a chance at it, a crack at it, and that will pass it to command 3. So going back here, the first few lines from these marks files will be cut by this. Maybe the first line is cut, passed on to cut. Meanwhile, this is starting on the second line, the cat. The cut passes on this first line to here. Cat's now on to the third. Cut is now on to the second. Sort is dealing with the first, for example. This is what we call the pipelined type of system. They're working in parallel to process each successive line here, and they're running at the same time. It's a very different situation than if you first had, say, cat run, put it out to a file, and then secondly, you had this cut run from that file with all the output from the first command ready and running through it, outputting to another file, and only then the third one run. This is a very important semantic difference. You can imagine, for example, maybe there's a fourth command line thing here. Since sort has to wait till all of them come, imagine it if instead of sort we had a different one, which would send an alert to someone, to an email address, for example, if it saw certain information provided into it. It would perhaps send mail off, in the midst of the whole process, and someone could come back to it and inspect what's going on, for example. So a significant advantage of using Unix pipelines in comparison with classic Windows or DOS pipelines is the capacity to run these things concurrently, run them in parallel. Okay, now there's an additional resource that you may want to use when we're dealing with pipelines, and that's the use of what's called T, the T command. T is very useful because it allows simultaneously writing a file to a stream, your output from command 1, writing that to a file called your file, as well as passing it on to command 2. So T will create a sort of thing that looks like a T. One part of it will go to a file, the rest will continue on to the next command. You can think of that part continuing on as the top of the T. It's stretching between here and here, and going to the file, it goes down into the file in the file system. So a copy is made of the stream at this point while it's passed on to command 2. That copy that will be in file is unsullied by whatever command 2 does. So it's not affected by what's happening downstream. It's simply placed in here. Okay. There's a set of additional ways we could, in a sense, compose commands in a less completely straightforward way than we have with pipelines. With pipeline, with the output from one going into the input from another, we can also create complex commands. That is, we can make the output from one the options and arguments for another, and we're going to be covering this in material later in the class. It's a straightforward thing in the Unix shell to have one command output when in essence are the arguments for another command, the command line arguments. Another possibility is to have one command depend not on the output from another command, but on the exit status. In other words, has it succeeded or failed? Has command 1 succeeded or failed, for example? What output code is it indicating? And finally, there's a straightforward way, and this is less conceptually deep, to have one command run before another command, but give them on a single command line. So, for example, we can group together things in a single command line that are conceptually associated with one another. So perhaps they're obvious to when you look at it at a single time. So here we're sharing tar options among a set of different processes, and we're updating them. Here we're entering a directory, doing an ls there. Will be even more compelling case will be something like where we so-called do a push D. We enter this directory, we do an ls, and then we do a pop D, so we come back to where we were originally. Nothing has changed as a result, except the ls is run, and presumably we put it in the results in a file. So you could put string things in a common command by separating them with a semicolon. Okay. I'm going to go on to discuss some issues with preventing shell interpretation, but I'll nuggetize this video first.